The bottom line, I simply want to make ever better car, no matter what kind of the powertrain they have.
Even though technology is advancing at a rate that blows our minds, no one could ever have guessed that there would come a day where you could get some water from the kitchen sink, pour into your car's tank, and be good to go on a trip to the supermarket or to another state. However, Toyota's announcement about an engine that will soon end the era of electric cars suggests that it is possible for car engines to run on water. But what are the odds that a car can run on only water without fuel or electricity? Stay with us as we explore the new and exciting advancements in car technology and discover all Toyota has to say about their new water engine. Toyota's new water engine. Toyota's latest innovation is likely to disrupt the car industry as we know it. Imagine a car powered by water. This mind-blowing vehicle uses an advanced electrolysis process to convert water into hydrogen, which fuels the engine. Its engine makes use of the chemical energy released during the recombination of hydrogen and oxygen to produce power, releasing only water vapor as a byproduct. This not only reduces harmful emissions, but also addresses the growing concerns about global warming and air pollution. Toyota's innovation promises a cleaner, greener future for transportation, aligning with global efforts to combat climate change. Although electric cars have been at the forefront of the green automotive movement for years, praised for their zero-emission status and their reliance on renewable energy sources, Toyota's water-powered car offers several unique advantages over traditional electric vehicles. While electric cars rely on batteries that require charging from the electrical grid, Toyota's water-powered car uses water, an abundant and renewable resource. The electrolysis process, which splits water into hydrogen and oxygen, can be powered by renewable energy sources such as solar or wind, making the entire system more sustainable. But that's not all. Electric cars have been marketed as zero-emission vehicles, but the production and disposal of lithium-ion batteries pose great environmental challenges and a large investment of resources. However, Toyota's water-powered car sidesteps these issues completely. According to the announcement made by the Executive Vice President and Chief Technology Officer Hiroki Nakajima at a recent meeting in Japan, Toyota plans to change the future of transportation with this new technology. Nakajima talked about Toyota's big plan to stop being just a car company and start being a mobility company that helps people have many options for movement. He was joined by two other leaders, Takero Kato, who is in charge of making electric cars, called BEVs, and Mitsumasa Yamagata, who will lead the team making hydrogen cars when the factory opens soon. Toyota's hydrogen fuel cell cars work by using a chemical reaction between hydrogen stored in the car and oxygen from the air to make electricity that powers the car. This system includes an important part called an electrolyzer. The process is very efficient and safe, as it doesn't need much energy and doesn't produce any harmful byproducts. One of the best things about this process is that it doesn't need a big, heavy tank to store the hydrogen. The electrolyzer can make hydrogen as it's needed, making the car lighter and more efficient. To use hydrogen fuel effectively, some parts of the car's motor need to be changed. The fuel injectors, which spray fuel into the engine, need to be adapted to spray hydrogen correctly. Also, the engine block and cylinder head need to be stronger to handle the high pressure of hydrogen fuel. Other parts like valves and spark plugs also need to be made specially to help the engine run well and safely. We'll get into the full details of how the process really works later, but keep in mind that Toyota's water engine is better than other motors that use hydrogen simply because it is much easier and cheaper to store water than to store hydrogen. Hydrogen is a gas, so it needs special tanks that can handle high pressure. These tanks are heavy, expensive, and can leak, which can be dangerous. Water, being a liquid, is much easier to store and doesn't need special tanks or high pressure, making it safer and more practical. This makes the water motor versatile, suitable for small cars, big trucks, and even power plants. Its simplicity and safety make it a better choice than other types of motors. Plus, It helps reduce our reliance on fossil fuels and cuts down harmful emissions. This makes it a more sustainable option for transportation and energy generation. However, it may surprise you to know that this whole motive to make a car powered by water only isn't exactly an original idea. The history of water vehicles. Before Toyota's steps to build cars that run only on water, there were others who tried to do the same. The number of claims and attempts are sure to blow your mind. In 2008, a Japanese company called Genapax announced they had made a car that could run on water instead of gasoline or diesel. This was big news because it promised a cheaper and greener way to power cars. Genapax said their car used a special system to get energy from water by splitting it into hydrogen and oxygen, then using the hydrogen as fuel. But experts found out that the system wasn't just using water. It also needed a special material called metal hydride. This meant the car wasn't truly water-powered. Genapax never provided scientific proof for their claims, and many scientists doubted their story. The scientists explained that water is very stable and you need a lot of energy to split it into hydrogen and oxygen. According to the laws of physics, you can't get energy from water alone because it takes energy to break the bonds holding the water molecules together. Some scientists also reminded people of Stanley Meyer, who in the 1980s claimed he had made a dune buggy that ran on water. But Meyer never showed solid proof and his claims were found to be false. He was even convicted of fraud in 1996. Genapax's story sounded a lot like Meyer's, and people were very skeptical. In 2002, hydrogen technology applications said they had a device called Aquagen that could split water into hydrogen and oxygen. They first used it for safer welding, but later claimed it could power cars. However, their theories weren't backed by science, and their claims seemed exaggerated. The company later admitted their device could only make cars more fuel efficient, not run on water alone. Another company, Genesis World Energy, claimed in 2002 to have a device that could get energy from water. They raised a lot of money from investors but never produced a working product. In 2006, the company's owner, Patrick Kelly, was jailed for fraud. In 2008, the same year Genapax made their announcement, a man in Sri Lanka named Tushara Priyal Desinga claimed he had driven a car on water for 190 miles using just 3 liters of water. The Prime Minister of Sri Lanka supported him, but Tushara was later arrested for fraud. His claims, like many before him, were exaggerated and misleading. More recently, in 2022, Arianto Misel from Indonesia claimed to have made a device called Nakuba that could turn water into hydrogen fuel. He said it could power motorcycles for 500 kilometers on 1 liter of water, and that big car companies like Lamborghini and Ferrari were interested. But scientists in Indonesia doubted his claims, saying the device was impossible according to physics. They also found out that the car companies weren't really interested. Arianto's story, like others, seemed to be more about making bold claims than having real proof. Despite these failed attempts and scams, we have to wonder if there has been a deliberate attempt to stifle the usage of water as fuel for vehicles. While we certainly can't prove that there have been suppressions, there are many reasons why this might be so. For one, the global energy industry, currently dominated by fossil fuels, is worth trillions of dollars. Introducing a technology that could make traditional energy sources a thing of the past threatens the financial interests of powerful corporations and stakeholders. These entities have enough resources and influence to suppress or discredit technologies that could threaten their market dominance. For example, fossil fuel companies have a vested interest in maintaining their market share and may lobby against or discredit alternative energy technologies to protect their profits. Another probable reason is that new and innovative technologies often face skepticism and resistance from the public and media. It is understandably hard for the public to understand how water could be used to fuel a vehicle, and the perceived risks, safety concerns, and lack of understanding can lead to negative publicity and hinder widespread acceptance. Powerful entities may also choose to exploit these fears to maintain control over the narrative and suppress these potentially disruptive technologies. For example, misinformation campaigns can create doubt and fear around new technologies, making the public less likely to accept them. However, with Toyota publicly stating its plans to develop these cars, while presenting evidence on how the science works, it is entirely possible we are about to see the dawn of a new age. Their influence in the mobility market, the trust they have built over the years, and their deep pool of resources suggest that we will see water vehicles become reality rather than just hearsay. And all this is as a result of Toyota's desire to stay ahead in a market that is moving towards clean technologies and electric vehicles, especially with new electric cars coming from companies like BYD and Xiaomi in China. It has led them to focus on making their hydrogen technology better and more efficient to meet the growing need for environmentally friendly transportation. This history of water-powered car ideas shows that while many claims might have been false, the push for greener energy solutions is real and important. Toyota's ongoing research has already produced a car, the Mirai, that is powered by hydrogen, and these advancements prove that a more sustainable future in transportation is possible. And there is still more to come. Comparison with China and America in electric vehicle production. It is common knowledge that in the race towards sustainable transportation, China and the United States have been leading the charge in electric vehicle (EV) production. China, with its aggressive policies and significant investments in EV infrastructure, has become the largest market for electric vehicles. Companies like BYD, NIO, and XPeng are heading China's EV revolution, benefiting from government subsidies, extensive charging networks, and robust manufacturing capabilities. The Chinese government's commitment to reducing carbon emissions and urban pollution has led to tough regulations that favor the adoption of EVs. As a result, China's EV market has seen fast growth, with millions of electric cars sold annually. The country's focus on developing battery technology and expanding its charging infrastructure has also played a crucial role in maintaining its position as a global leader in EV production. In contrast, the United States, home to top companies like Tesla, has also made significant strides in the EV sector. Tesla, under the leadership of Elon Musk, has revolutionized the market with its innovative designs, cutting-edge technology, and an expansive supercharger network. The company's commitment to improving battery efficiency and range is continually increasing standards for the industry. To add to this, legacy automakers like General Motors and Ford have shifted their focus towards electric vehicles, introducing new models and investing heavily in EV technology. However, despite the progress in EV production, both China and the United States face challenges related to the environmental impact of battery production and disposal, as well as the need for sustainable energy sources to charge these vehicles. This is where Toyota's water-powered car presents a unique advantage. Toyota's innovation in developing a vehicle that runs on hydrogen derived from water sets it apart from the traditional EV approach. Unlike battery electric vehicles (BEVs), which rely on large lithium-ion batteries, Toyota's water-powered car utilizes hydrogen fuel cells. This difference not only addresses some of the environmental concerns associated with battery production, but also offers a cleaner alternative in terms of emissions. By producing only water vapor, Toyota's engine eliminates the release of harmful pollutants such as carbon dioxide, nitrogen oxides, and particulate matter, which are common with fossil fuel-powered vehicles. On top of that, Toyota's hydrogen fuel cell technology offers several advantages over conventional batteries used in electric vehicles. For instance, hydrogen fuel cells can be refueled much faster than recharging a battery, often taking just a few minutes to fill up a hydrogen tank compared to several hours needed to recharge a battery. This makes the water-powered car more convenient for long-distance travel and reduces downtime for refueling. Another major advantage of hydrogen fuel cells is their higher energy density compared to lithium-ion batteries. This means that hydrogen fuel cells can store more energy per unit of weight, potentially providing a greater driving range for vehicles. Plus, hydrogen can be produced using various renewable energy sources such as solar, wind, and hydroelectric power, further enhancing the sustainability of this technology. Toyota's approach also addresses some of the key challenges associated with hydrogen production and storage.
The company has developed advanced electrolysis units that are more efficient, reducing the overall energy consumption required to produce hydrogen from water. These units use cutting-edge catalysts and materials to enhance the efficiency of the electrolysis process, making it more viable for large-scale production. In terms of hydrogen storage, Toyota has innovated with high-pressure tanks made from advanced composite materials. These tanks are designed to be both lightweight and extremely durable, ensuring the safe storage of hydrogen under high pressure. The storage system is equipped with state-of-the-art sensors and safety features to detect and prevent leaks, providing an additional layer of security. Toyota has also addressed the challenge of operating hydrogen vehicles in cold climates. Hydrogen can freeze at extremely low temperatures, potentially affecting the vehicle's performance. To overcome this, Toyota developed innovative solutions such as incorporating heating elements and insulation into the hydrogen storage system. These measures ensure that the vehicle can operate reliably even in harsh winter conditions, making hydrogen vehicles viable in a wider range of environments. Toyota's commitment to integrating renewable energy sources into the hydrogen production process aligns with global efforts to reduce reliance on fossil fuels. By using solar, wind, and hydroelectric power to generate hydrogen, Toyota's water-powered car can operate with a minimal carbon footprint, making it a truly green alternative in the automotive industry. Toyota's commitment to eco-friendly technology. Great things rarely start suddenly, and Toyota's commitment to eco-friendly technology goes far beyond its development of hydrogen fuel cell vehicles. The company has been a pioneer in both hybrid technology and the exploration of alternative fuels. One of the notable areas of focus has been the development of hydrocarbons that have a reduced environmental impact. Hydrocarbons, in their conventional form, are fossil fuels such as gasoline and diesel, which contribute significantly to carbon emissions. However, Toyota has been exploring the use of synthetic hydrocarbons and biofuels that can serve as cleaner alternatives. Synthetic hydrocarbons are produced through chemical processes that convert carbon dioxide and hydrogen into fuels, effectively recycling CO2 and reducing the net carbon footprint. Biofuels, derived from organic materials such as plant biomass, animal waste, and algae, present another promising avenue. These fuels are renewable and can be produced sustainably. Toyota has invested in research to improve the efficiency of biofuel production and to integrate these fuels into their vehicle lineup. By researching and developing these alternatives, Toyota's goal is to provide immediate solutions for reducing emissions while the infrastructure for hydrogen and electric vehicles continues to expand. But there's still so much more. In addition to hydrocarbons, Toyota has also made major developments in fuel cell technology. The core of Toyota's eco-friendly vehicle strategy lies in hydrogen fuel cells, which convert hydrogen gas into electricity through a chemical reaction with oxygen. This process produces only water vapor as a byproduct, making it one of the cleanest forms of energy. Toyota's first fuel cell vehicle prototype was unveiled in the early 1990s, and the technology has evolved substantially since then. Today, Toyota's fuel cells are more efficient, compact, and cost-effective. The advancements in fuel cell technology have been driven by improvements in catalyst materials, membrane durability, and overall system integration. As of recent reports, Toyota holds over 5,000 patents related to hydrogen fuel cell technology. These patents include key advancements in fuel cell stack design, hydrogen storage solutions, and methods for efficient hydrogen production. By securing these patents, Toyota not only protects its technological innovations, but also positions itself as a leader in the transition to sustainable transportation. We must not forget to mention one of the most significant milestones in Toyota's journey towards eco-friendly technology, which is the introduction of the Mirai, the world's first mass-produced hydrogen fuel cell vehicle. The Mirai, which means future in Japanese, embodies Toyota's vision for sustainable mobility. Launched in 2014, the Mirai has since undergone several updates and improvements, reinforcing Toyota's commitment to advancing fuel cell technology. The Mirai operates using a hydrogen fuel cell system that generates electricity through a chemical reaction between hydrogen and oxygen.
This system consists of several key components, including the fuel cell stack, high-pressure hydrogen tanks, an electric motor, and a battery for energy storage. The fuel cell stack, often referred to as the heart of the vehicle, is where the electrochemical reaction occurs, producing electricity and water vapor. One of the notable features of the Mirai is its impressive driving range and refueling time. With a full tank of hydrogen, the Mirai can travel over 300 miles, comparable to many gasoline-powered vehicles. Refueling the Mirai takes only about 5 minutes, significantly faster than recharging an electric vehicle. This convenience makes the Mirai a practical choice for consumers looking for an eco-friendly vehicle without compromising on usability. The environmental benefits of the Mirai are substantial. By emitting only water vapor, the Mirai eliminates tailpipe emissions, contributing to cleaner air and reduced greenhouse gas emissions. Toyota has also taken steps to make the Mirai accessible to a wider audience. The company has implemented various initiatives to reduce the cost of hydrogen fuel cell vehicles, including advancements in manufacturing processes and economies of scale. Furthermore, Toyota has been actively involved in partnerships and collaborations to expand the hydrogen refueling infrastructure, making it easier for consumers to adopt hydrogen vehicles. Beyond the Mirai, Toyota's commitment to hydrogen technology extends to other vehicle segments. The company has developed hydrogen fuel cell buses and trucks, showcasing the versatility of this technology in different transportation applications. These vehicles are designed to provide clean and efficient transportation solutions for public transit and commercial operations, further reducing the carbon footprint of the transportation sector. In addition to its vehicle offerings, Toyota is exploring the use of hydrogen fuel cells in stationary applications. The company has developed hydrogen-powered generators and energy systems that can be used in buildings, data centers, and other facilities. These systems provide a reliable and sustainable source of energy, further demonstrating the potential of hydrogen technology beyond the automotive industry. Toyota's approach to eco-friendly technology is holistic and forward-thinking. The company recognizes that achieving a sustainable future requires a multifaceted strategy that includes not only innovative vehicles, but also the development of supporting infrastructure and sustainable energy sources. The electrolyzer process explained. The way Toyota's hydrogen fuel cell products work is by using a chemical reaction between the hydrogen stored in the vehicle and the oxygen in the air around us. This reaction produces electricity which powers the car. It's a very clever and efficient way to make cars run without harming the environment. The motor has a special part called an electrolyzer. This part takes in water and uses a process called electrolysis to split the water molecules into two different things, hydrogen and oxygen. Water is made up of 2 hydrogen atoms and 1 oxygen atom stuck together. The electrolyzer uses a special kind of energy, called electricity, to break these atoms apart. The electricity is sent through 2 special pieces of metal called electrodes. These electrodes are put into the water, and when the electricity flows through them, it makes the water molecules start to break apart. The hydrogen atoms are attracted to one of the electrodes, and the oxygen atoms are attracted to the other electrode. This means that the hydrogen and oxygen are separated from each other. The electrode that the hydrogen is attracted to is called the negative electrode or the cathode. The electrode that the oxygen is attracted to is called the positive electrode or the anode. When the electricity flows through the electrodes, it makes the hydrogen atoms move to the cathode and the oxygen atoms move to the anode. This process is very efficient and safe, as it doesn't need a lot of energy to happen, and it doesn't produce any harmful byproducts. The only thing that comes out of the electrolyzer is hydrogen and oxygen. The hydrogen can then be used as fuel for the motor. The motor converts the electrical energy from the fuel cell into mechanical energy, driving the wheels. The power control unit plays a crucial role here, managing the flow of electricity from the fuel cell stack and the battery to the motor, ensuring efficient power distribution for smooth acceleration and regenerative braking. The fuel cell stack generates electricity through the electrochemical reaction between hydrogen and oxygen. This produces direct current, DC electricity, which is then converted to alternating current, AC, by an inverter to power the motor. During braking, the motor acts as a generator, converting kinetic energy back into electrical energy that's stored in the battery. This not only enhances efficiency, but also adds to the overall driving experience. But there's still more. Electrolysis itself is not 100% efficient. Traditional electrolysis systems can have efficiencies around 60 to 70%, meaning that 30 to 40% of the energy used is lost as heat. Recent advancements, however, have pushed the efficiency of advanced electrolysis systems closer to 80% or higher. These improvements are largely due to better materials, more efficient catalysts, and optimized operating conditions. Once hydrogen is produced, it is stored and used in a fuel cell to generate electricity. Fuel cells typically have an efficiency of around 50–60%. This means that when you combine the efficiency of electrolysis and fuel cells, the overall efficiency of converting water to usable electricity in a vehicle can be around 40–50%. While this may seem low, hydrogen fuel cell vehicles typically have a longer range compared to battery electric vehicles, BEVs, because hydrogen has a higher energy density. This means that despite the 40–50% efficiency, the amount of energy stored as hydrogen can provide substantial driving distances. Toyota's plans for a future of mobility. Under the banner, "Let's change the future of cars," Toyota Motor Corporation, Toyota, has announced a range of new technologies that will support its transformation into a mobility company. Toyota has ambitious plans for hydrogen, focusing on expanding its use and commercial viability across multiple sectors. They project that hydrogen markets in Europe, China, and North America will become the world's largest by 2030, with the fuel cell market expected to reach approximately 5 trillion yen, about £5.7 billion annually. To capture a significant share of this market, Toyota is working to enhance its hydrogen business through several key initiatives. Toyota will establish a new hydrogen factory in July 2024 to streamline decision-making and operations related to hydrogen fuel cells. This facility will centralize development, production, and sales functions under one leadership structure, enabling quicker responses and more cohesive strategies. The hydrogen factory's strategy is threefold. First, it aims to localize R&D and production in key global markets, such as Europe and China. This localization will accelerate efforts and adapt products to regional needs. Second, Toyota plans to strengthen alliances with leading partners to consolidate fuel cell supply and reduce costs, making hydrogen fuel cells more affordable for customers. Third, the company is committed to advancing next-generation fuel cell technologies to enhance competitiveness and performance. The goal is to reduce the cost of fuel cell stacks by 50% and achieve a 37% cost reduction in the next generation of systems. Toyota expects to further reduce costs by 50% if they receive orders for 200,000 units by 2030, aiming to secure solid profits and meet customer and government expectations. Toyota is also addressing the high cost of hydrogen production. They are working with partners to improve hydrogen production, transportation, and usage. Initiatives include the production of hydrogen from biogas derived from local chicken manure and food waste in Thailand, in collaboration with Mitsubishi Kokoki Corporation and Toyota Tsusho Corporation. Additionally, Toyota has developed a new water electrolyzer to produce hydrogen, building on the technology from the Mirai's fuel cell units. To advance hydrogen use, Toyota is developing a multi-hydrogen tank concept that allows for easy installation and compatibility across various vehicle types and sizes. This will enable the conversion of existing vehicles to use hydrogen fuel cells and combustion engines. In the commercial sector, Toyota is focusing on hydrogen-powered large commercial vehicles and is working to standardize tank sizes to reduce costs and increase demand. They are also exploring liquid hydrogen tanks for large commercial vehicles. Hydrogen engine vehicles are another area of development for Toyota. They have created a trial hydrogen engine vehicle, which has been licensed for public road use in Japan. This vehicle will help accelerate the commercialization of hydrogen engines, contributing to carbon neutrality. Toyota's efforts also include reducing the price of hydrogen. They are collaborating with industry partners to promote hydrogen production and make it more economically viable. Their aim is to establish customer-oriented bases in major markets and offer affordable hydrogen products in sufficient quantities. From the plans Toyota has laid out, it is evident that very soon car engines will soon indeed run on water. Will Toyota's new engine really replace and end electric cars? Share your thoughts with us in the comment section. Remember to like, share, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.